All right, now I'm ready.
Okay. I thought
Hold on a second. Could you start over again? I think most of us missed out on that.
Okay, so I think it's exponential because it goes up by more every time.
So when you say it goes up by more, let's show that. What's the difference from 6 to 18?
Well.
Okay. What's the difference between 18 and 54?
36.
Clearly it's not linear. Okay, so we've proven it's not linear. All right. So then what's the next thing you tried?
I tried. Well, I know that 6 times 3 is 15.
Ooh.
And then
Okay, and your audio is really really soft, so make sure you're screaming into the mic.
Okay.
Oh, that's much better.
Okay, yeah.
Okay, so you notice that you're multiplying by 3 every time, and that is the hallmark of an exponential relationship, okay?
Okay. Yep.
So we can safely say this is exponential. All right, so, and we know, and I'm going to give a little extra background and then you can fill in. We know that in exponential relationships, you will have an expression in y equals a times b to the x power, where a is the y-intercept and b is the growth factor. All right, so what was the equation that generated this table?
Y equals 6 times 3 to the power of x.
Y equals 6 times 3 to the power of x. All right, so let's double check this. If a is our y-intercept is in fact 6, okay. So that checks out. And our growth factor is what we're multiplying by, so that is 3, so that also checks out. That's absolutely perfect. Good job, Layla. All right, do we have a volunteer for the middle table?
Jake.
Jake! Is this Jake from State Farm? Just kidding.
Okay, so I knew that they were increasing by 3 every time.
So is that adding 3 or subtracting 3 or multiplying by 3?
Oh, adding 3.
Okay.
For all of them. And so using that math, I realized that the slope was 3. And then
So hold on a second. Hold on. You said slope. So what kind of relationship are we talking about here?
Oh, linear.
Okay, so this is definitely linear.
And I used our rate that we're adding 3 every time to get a y-intercept of -7.
Excellent.
And so I came up with the equation of y equals 3x plus -7. I mean, yeah.
All right. So the calibration on my board is a little bit off, so if my handwriting looks worse than normal, that's why. I'm sorry. Jake, you did an excellent job of explaining this one. It is clearly linear. All right. Is there a volunteer for the third table?
Why is it -7?
Why is it -7? Because so we're working backwards, and
So you're subtracting.
right. So we know we have to add 3 from this term to get to -4. So what plus 3 is equal to -4? Well, it's -7. You're welcome. Okay, volunteer for the third table.
Avery.
All right, Avery.
Alright, so this one is exponential because you have to multiply by 4 every time.
Okay, so
Because
Okay, so you said you're multiplying by 4 every time, okay?
yeah, and so if it's exponential, I know our equation has to be y equals a times b to the x power.
Okay.
So, and the y-intercept is when x equals 0, so that is 0.875. 0.875, and our growth factor is 4. So it's 0.875 times 4 to the x power.
All right. Are there
To the power of x.
to the power of x, or to the x? Either way, you said it was fine. Great job, guys. Are there questions so far on finding the equation from an exponential table?
No.
Okay. Hopefully the explanation videos from yesterday were helpful. I'm guessing it was because we had no problems with this warm-up. Great. All right, so here's what we have for today. Maybe. We are going to recognize an exponential growth situation based on a real-life situation. And to be honest with you, we can actually do an extra credit experiment. I do not believe in extra credit normally, but in this case, this investigation is way too much fun to not do an extra credit experiment. So we'll talk about that later. Maybe if we can go to the other page. There we go. All right, we are growing mold. Yay! It looks much better. Moldy bread. How many of you?
My friend looks nasty.
How many of you are hungrier now than you were a moment ago?
Yes,
sir.
That's right. Nothing's wrong with a little penicillin, right? Okay.
That looks so good.
Oh yeah. It looks like a full week out of school and in the hospital. Okay, so mold can spread very rapidly. For example, the area covered by mold on this loaf of bread left out in warm weather grows exponentially. That is a very true statement. Students at Magnolia Middle School, I used to have a magnolia tree in my yard, but then it died in the drought. It was kind of sad. It was the second largest magnolia tree in the city of Denver, but now it's gone. All right, so students at Magnolia Middle School conducted an experiment. They set up a shallow pan containing a mixture of chicken bouillon, gelatin, and water. Each day, the students recorded the area of the mold in square millimeters. The students wrote the exponential equation m is equal to 50 times 3 to the d power to model the growth of the mold. In this equation, m is the area of mold in square millimeters and d is in days. I have one little note on notation. You will notice that in the textbook, they will always put the exponent inside the parentheses, whereas I will always put the exponent outside the parentheses. These are equivalent statements. Since we have 3 to the d power, we're taking 3 to however many days we've been looking at the mold. In the way I like to show it, same thing. We're taking 3, or everything in the parentheses, in which case this is just 3, to the power of d. The reason why I prefer my way is because it's my way. No, the reason why I prefer my way is this. Right now we're dealing with integers. Everything is a whole number, but in reality we rarely will see exponential growth that is a perfect whole number. It's going to be a fraction of some sort. So when we are starting to deal with a fraction, let's say it's 3 over 2, I've had troubles with students thinking only the 3 in the numerator gets the d power, when in reality it's 3 halves, the whole number 3 halves, that gets to the power of d. So to alleviate that misconception, that's why I like to show the exponent on the outside of the parentheses, to show that we're actually doing the whole fraction, 3 over 2, to whatever power that is. Are there questions on the notation and why there's a difference in the textbook versus what I show in class?
No.
Okay. All right, so the questions we have: what is the area of mold at the start of the experiment? And again, you're using that equation. What is the growth factor? What is the area of mold after 5 days? On which day will the area of mold reach 6,400 millimeters square? Now, if it's not on an exact day, just give me between which 2 days, that's fine. And then in question E, an exponential equation can be written in the form y equals a times b to the x, where a and b are constant values. What value does b have in the mold equation, and how is that represented? And same question for the a value. This is not going to take more than 10 minutes. Are there questions about what I'm asking you to do today?
Nope.
All right. I need you to go to your common rooms, work in your large common rooms, and you are going to come back here to Math Fun at 8:55. Is that clear?
They're going.
Go. 8:55 it is.
I thought you were bringing scales.